Okay, welcome back to a few videos on metric prefixes and then unit conversion. And we do have to talk about the metric system because that's our primary system of measurement in physics class and in any science class it should be. You studied the metric system to some extent back in 6th grade. And there's always arguments for why do we have to learn the metric system, our system of measurement is just fine. I understand all of that, but let me just point something out to you. Think about all the different measurements that we use in America. We say that 12 inches, well, okay, that one's pretty easy. We know that that's a foot, and that's pretty normal for us. We also have this measurement where 36 inches is the same thing as 3 feet, which is the same thing as 1 yard. Okay, that one's a little strange. Why 3? We had 12 inches was a foot. Why are we now saying that 3 feet equals 1 yard? That would be 36 inches. That's kind of weird, but whatever. Now here's the really weird one. Someone at some point decided a long time ago that 1 mile was 5,280 feet, which is the same as saying 1,760 yards, which is the same as saying 63,360 inches. Now, some people, and I particularly, I tend to remember this one very well. 1 mile is 5,280 feet. But who in their right mind would remember these conversions between miles and inches? How many yards are in a mile? How many inches are in a mile? Even knowing how many feet are in a mile is not all that common. That's weird. It's just a weird system of measurement. It's strictly by tradition. There's no logic in it whatsoever. Another example is that 16 ounces, if we're talking about mass, equals 1 pound. And then someone just kind of arbitrarily decided that 2,000 pounds, which is equal to 32,000 ounces, equals 1 ton. There's no rhyme or reason to that whatsoever. There are a number of advantages, on the other hand, to the metric system. One of which is that all of the different measurements in the metric system are orderly and logical. Once you learn it, it's very, very easy to use. The reason the metric system is so much easier to use is because it starts off with a bunch of what we call base units. These are things that we've talked about before, like meters, grams, seconds, etc. I call them base units because we can then attach prefixes to them. You know what prefixes are from English class. They're parts of words that go on the front of other words to slightly change the meaning. So we can take these base units and we can add prefixes to them to change the size of the measurement we want to talk about. For instance, let's say you got something really big that you don't want to talk about how many meters it is. You want to use a bigger unit. You attach a prefix to meter, depending on the size, that can help you to describe something that is much bigger or much smaller than a meter. For instance, you got something that's 3,000 meters long. Perhaps you don't want to say, 3,000 meters is tough to picture. However, if you're familiar with a kilometer, you can say that that thing is 3 kilometers long or 3 kilometers in distance. And if you're familiar with what a kilometer is, or a kilometer, depending on how you want to pronounce it, that makes a lot more sense. In your Regents physics reference tables, there is this table, there's this chart on the very front page, prefixes for powers of 10. This is the guide to the metric system. Okay? It lists out what all the prefixes are and what they mean. The symbol column is what you would put in front of the base unit. So for example, if instead of talking about a gram, you want to talk about a kilogram, you look at the symbol for kilo, which is lowercase k. Symbol for the unit for gram would just be g, so a kilogram is kg. Gigameter. Meter is just m, giga is a capital G, so you write gm, and so on. The prefix names are all listed here: tera, giga, mega, kilo, deci, centi, milli, micro, nano, pico. There are many more than that. These are just some common ones. The important part for you guys is this notation column. Okay? The notation column tells you, make sure you take your time to understand this, how many base units equal 1 prefix unit. So for example, e.g., let's say that you have 1 terameter. Okay? You want to know how many meters, the base unit, are equal to 1 prefix unit, the terameter. Well, this notation for tera is 10 to the 12th. So what that means is that 1 terameter is 10 raised to the 12th meters. Very simple, very logical. If you want to know how many meters are in a kilometer, you look here, you see 10 to the 3rd, and you say, okay, 1 kilometer is 10 to the 3rd meters. And actually, before we go any farther, let's talk about what these notations mean. Let's start with a simple one, 10 to the 3rd. Remember, exponents just mean, if you have 10 to the 3rd, it just means multiply 10 times 10 times 10, and that means 1,000. Matter of fact, on my calculator, you could even just do this. Type in 10, and this button here means exponent. 10 raised to the 3rd is 1,000. So I'm just going to write 1,000 right here. 10 to the 6th is 1,000,000. 10 to the 9th is 1,000,000,000. 10 to the 12th is 1,000,000,000,000. Going the other way, 10 to the -1st. Remember, that's going to be a small number. 10 raised to the -1st. Look at that. It's 0.1. You could write that as a tenth. 10 raised to the -2 is 0.01. That's not a tenth, that's a hundredth. And then going down, you have thousandth, millionth, billionth, and trillionth. Notice that all of these are fractions. Okay. And notice that these are the big numbers up here, and these are the small numbers down here. So it's important to understand relative sizes. A pico something is smaller than a nano something, even though both of them are very, very, very small. Okay? By the way, you can also go the other way. You can also talk about how many prefix units fit into one base unit. To find how many prefix units equals one base unit, all you do is you simply switch the sign on the notation. So, in other words, if you want to know how many terameters are in 1 meter, you would say 1 meter equals, the symbol for tera is 10 to the 12th, so 1 meter must be equal to 10 to the -12th terameters. Okay? So you need to know how to relate these prefix units back to the base unit. That's the key here. You need to know how they relate. All right? And again, just to kind of chill you out about this, because people get freaked out about this all the time. Kilo means 1,000. If you have a kilometer or a kilometer, that means that there are 1,000 meters in that kilometer. If you have a megameter, 10 to the 6th, what that means is that there are 10 to the 6th meters in that megameter. It could also mean that in 1 meter, there is 10 to the -6th megameters. In other words, a meter is a very small fraction of a megameter. Centi, 10 to the -2nd, means that there are 10 to the -2nd meters in 1 centimeter, and that makes sense because you know that a centimeter is very small. On the other hand, there are, in 1 meter, there are 100 centimeters. If that's confusing to you, please make sure try and rewatch this. Try and rewatch this a couple times so that you can understand this. Okay, this is crucial stuff. And if you still don't quite get it, we'll talk about it enough in class. The math, knowing the relative sizes is important, and really just being able to read this table. But with practice, you'll get it. Okay, what we're going to talk about now is unit conversion. We're going to do one example here, and then we're going to go to the back and do a few examples, and we'll be done with this video. Unit conversion is, and you've done unit conversion before, even if you haven't called it unit conversion. The point of unit conversion is to figure out, okay, well, if I have this measurement in a certain unit, and let's say I want to know what the value would be in another unit. For example, how many meters are in a kilometer? In this case, your unit that you have is kilometer, but you want to know, okay, well, how many meters are in that kilometer? Now, this is kind of a silly question. It's a very obvious answer. There's 1,000 meters in a kilometer. Okay, we just talked about that up here. But I'm going to show you a process that is foolproof. As long as you follow the rules, it is completely foolproof for converting from one measurement to the next. Okay, so it's very important that you learn this. Sometimes people fight me on this. They say, I don't want to do it that way. Well, if you don't want to do it that way, you're fine to do it whatever way you want, but when it comes to the hard conversions, you will typically not get them right. If you follow this method, you're set. Okay, to convert from one type of measurement to the next, the first thing you're going to do is write the number that you are trying to convert with the current units. Right now, we're talking about a kilometer. We want to know how many meters are in that. Again, I know it's an easy problem. I'm showing you an easy problem to illustrate the process. So right now, we have 1 kilometer, okay, 1 km. We wrote that down. In order to unit convert, what you're always going to do is you're going to multiply by a fraction. You're going to put parentheses around the fraction, okay? That fraction will consist of 2 equal measurements. One measurement in the numerator, one measurement in the denominator that are exactly equal to each other. One of those measurements will be in the units that you're currently in this case kilometers. The other one will be in the desired units, the units you're trying to convert into, in this case meters. So kilometers and meters, the units for those are either going to go on the top or the bottom. And the way to figure it out actually goes back to algebra a little bit. If I were to give you, let's say, this example, 2 times 7 over 2, and I were to say, hey, solve this for me. What is 2 times 7 over 2? The majority of you would very quickly say, oh, that's got to be 7. And I would say, okay, how'd you get that? And you might say, well, this is really 2 over 1. We multiply by 7 over 2. We have a 2 on top. We have a 2 on the bottom. We cross those off. We get 7 over 1, which is just the same as 7. So you see that numbers, if they're on top and on bottom, can be canceled out. If I said, okay, what is x times y over x? You would say, well, again, you have an x on the top and x on the bottom. They cancel out. That just gives you y. That's basic algebra that you learned how to do a long time ago. It turns out that units work the same way. We can think of this 1 kilometer as being like 1 kilometer over 1, and it's getting multiplied by something. So we have a kilometer on top. If we want to get rid of that unit of kilometers, we should put it on the bottom, right? Because then our kilometers will cancel out. If we put our units of meters up here, then when it cancels out, we'll be left with meters. Now, that's the majority of the setup. All you have to do now is figure out the equal measurements. If you have kilometer down here and meter up here, what are the numbers you should fill in so that the measurements are the same? Well, we know from the chart that kilo means 1,000. So that means that 1,000 base units, meters, is equal to 1 kilometer. So I'm going to put 1,000 up here, 1,000 meters, and 1 kilometer. Again, notice 1,000 meters is equal to 1 kilometer. Once you've got this set up, so the process is, open up your parentheses, write your fraction bar, figure out where the units are going to go first. Once you figure out where the units are going to go, then put in your numbers. Okay? Now you just do the math. Okay, we know that this was 1 kilometer down here, 1,000 meters. We know this cancels out, we're left in meters. Now, what you're going to do now is just the math. 1, remember, anytime you have a fraction, if you have this 1, you would multiply it by the 1,000, 1 times 1,000, and then you divide by whatever's on the bottom. Divide by 1 is 1,000. And in this case, the answer is very obviously 1,000 meters. There you go. All you've done right there is you've unit converted 1 kilometer to 1,000 meters. And again, I said this is the really easy example. let me show you something, and it might be a little confusing. You might be like, why are we even doing this example? Let me show you a case where this might be a little bit easier or more useful. I want to look actually not even at 1, 2, 3, 4, 5, 6. I want to look at 7. Time conversions are really useful to you. Time conversions are actually a little bit easier because you've probably done these before. You might want to know, okay, well, a half hour or like 2 hours, how many minutes is that? You might say, oh, 120. All right, 4 minutes, how many seconds is that? 240. How many seconds are in an hour might be something you've asked before. You're a little bit more familiar with time conversions at this point, so let me show you a couple examples of time conversions. Let's say you want to take 142 seconds and convert it into minutes. Let me follow the process. I'm going to write down 142 seconds. I want to convert to minutes. So at this point, I'm going to open a set of parentheses and write a fraction bar. I want to get rid of the units of seconds, and I want to get into minutes. I have seconds here. In order to cancel this seconds out, remember this is really like 142 over 1, I can write the units of seconds down here. That way I have seconds on top, seconds on the bottom. They'll cancel. I want to be in minutes. I'm going to put minutes on the top. Now comes the part with the math. How many, what could I put so that I have equivalent measures here and here? Well, I know that 1 minute is equal to 60 seconds. So now I do the math. In doing this math, what I'm going to end up doing is take 142 times 1 divided by 60. So really, it's like I'm just taking 142 and dividing by 60. I don't even have to really write the times 1. If I take 142 and divide by 60, I get 2.37 minutes. And that's the answer. 142 seconds is 2.37 minutes. Now, could someone say, well, why didn't you just divide? It's very obvious you have to divide. That's fine. That's a very simple conversion. However, it's not always going to be that simple, and sometimes people get stuck between should I divide, should I multiply, and they'll get it wrong. If you follow the unit conversion process, you will never be led astray. Let's do a more complicated example. Let's do one where we have multiple conversions that we're going to do at once. How many seconds are in a week? This one you don't know off the top of your head, and it's not very obvious what you should do. We start off with 1 week. Now, I don't know how many seconds are in a week, but I do know how many days are in a week. There's 7 days in a week. So let's convert instead to days first. I know in 1 week, there's 7 days. If I were to stop right there, I would get 7 days as my answer, but I want this in seconds. One of the nice things about unit conversion is you can just kind of keep going until you get your desired units. Now that I have days, well, I don't know how many seconds are in a day, but I do know how many hours are in a day, 24. I'm going to convert from days, which is up top, so I'm going to write it down here, to hours. In 1 day, there's 24 hours. I'm not done yet. I don't know. I actually do know off the top of my head how many seconds are in an hour, but that's not something that everyone knows. So instead, I'm going to convert from hours to minutes. You see how I'm just using what I know. Because hours is up here, I want to cancel out of hours. I'm going to write it down here. I'm going to write minutes up here. In 1 hour, there's 60 minutes. If I were to stop now and do all this math, I would simply have how many minutes are in 1 week. But I don't want to stop there. I want to get all the way to seconds. In 1 minute, there's 60 seconds. Now, I should be completely canceled out with all units, and now I'm in seconds. So now all I do is I do the math. I take 1, I multiply by 7, times 24, times 60, times 60. 1 times 7, times 24, times 60, times 60. And it turns out that there are 604,800 seconds in 1 week. So I showed you a couple of things there. I hope you understand a little bit better the process of doing unit conversion. The only reason that there's like 4 little terms here is because I had to convert multiple times. If you knew off the top of your head how many seconds were in a day, you could have ended right here. You could have written down 1 day equals, I think it's 86,400 seconds. But we didn't know that. We just used what we knew. Okay? There's not a set process for this. I guess the set process is setting it up like this. setting it up so that you have units that will cancel out. Okay, that's the most important part. So I showed you a couple things. I showed you that you can do unit conversions with time. You can do it with any sort of measurement, but time usually works for a lot of people. And you can do multiple unit conversions at once. Now, could you have kind of taken a break in between, got 7 days, and then 168 hours, and then some amount of minutes, and then some amount of seconds? Yeah, sure, but that's more writing for you. You can also chain your unit conversions up like this. When we come back, we'll do a whole bunch of examples, and I think we'll still have a couple left, but when we come back for the next video, we'll see a lot of those examples. Okay?